Okay, good morning, everyone. Okay, good morning, everyone. Welcome to the GenAI initiative for NRENs in the Asia Pacific region. This is basically a workshop called AP Gained, or Asia Pacific Generative AI for NREN Empowerment and Development. This is an APNIC ISIF impact grant that we received in collaboration with BD-REN and the APU in Malaysia, Asia Pacific University in Malaysia. This was actually based on a workshop that we did in Sri Lanka for capacity building in generative AI. And we are specifically targeting the NREN staff, but I mean, it's not limited to, because after all, the operations, what you do, and all these are common to everyone. The target is NREN staff, but it applies to everybody. We are also looking at targeting the least developed countries and lower middle income countries, but once again, it's not limited to those countries because this can be applied globally and for everybody. A quick look at what inspired this series of workshops. As I mentioned, we did a workshop in Sri Lanka last year called AID. It's AI for Innovative Design and Education, which we did in March last year in Kandy, Sri Lanka, done by the APU UNESCO chair at APU. This had a few modules, basically targeting different sectors like AI Teach, targeting primary and secondary education, AI Learning Design, targeting higher education, AI RE or research for research purposes, AI AW for academic writing, AI HP for health professionals, and AI Leap for administrative efficiency. So we looked at how we can extend this to the NREN staff and operations, mainly administration, as well as networking, operations, systems administration, and so on. To look at why we are saying that we are targeting LDCs and LMICs is specifically our NRENs are kind of struggling with lower funding and lack of resources, lack of resource persons, and so on. So we are trying to see how we can divide this, bridge this digital divide, as well as address the gender equality and social inclusiveness. So the key outcomes of this project is to come up with a tailored GenAI curriculum and training material to improve the NREN staff AI capacity. As once again, not just NREN staff, but staff AI capacity, and specifically focusing on a practical skill development. This is not something that I'll mention. This is not something that we are going to just tell you how to do, but most of the thing will be actually getting us to do different activities so that we can look at how we can integrate this into day-to-day work and life. Based on that, we are hoping to come up with an open education resource, so just not limiting to these workshops, but with your support, with others who participate in this workshop, the support of everybody, we hope to create an open education resource where we'll be hosting free of charge for anybody to actually go through and learn and apply this, and a platform that we can share common use cases, best practices, and so on. So that we can actually grow as a community with peer learning, learning from each other, and building a strong community that can exchange these use cases, best practices, and so on. So we are hoping by the end of it, we'll have strong NRENs across the region, in spite of or despite of the economic standards and so on. The key activities of this, actually we got this grant during last APAN, so we got the announcement, but we actually started working on that in the last APAN, or APAN58 in Islamabad, Pakistan. So the first workshop we had, so we called it now Activity 0 because it's not part of the official activity list, but we started with a workshop in the last APAN where we did kind of a need analysis of GenAI and AI knowledge, and had a couple of sessions on introduction to AI and prompt engineering. And then we started off the actual activities in Malaysia with the help of the UNESCO chair at APU, Asia Pacific University in Kuala Lumpur, to come look at developing this curriculum as well as training the trainers. So that's a photo from that. And then we had two local workshops in Sri Lanka and Bangladesh. So just to further revise the test this curricula, further revise it, generate use cases, and also do the training on those countries. So they had it in January and February. And the next set of activities is these two regional workshops. One we are doing now, and the next one will be done in APAN60 in Hong Kong. Once again, to have a regional impact, to exchange knowledge, community building, and showcase of success. So once again, as I said, this is not for us to come and tell you how to do these things and so on. There are people in the audience who are actually teaching AI and using AI day to day, developing AI-related, GenAI-related activities and so on. So this is an attempt to actually work together to come up with a community and a knowledge base so that we can actually strive together and work together and improve everybody and everybody's work life. The next one, as I said, to develop this educational resource, we were hoping to host it in APNIC Academy. So we need to, we are working on that one, or we will host it in a different platform. We also hope to disseminate this knowledge through other publications so that these efforts can be used by globally by other people to see how we can apply this in across the globe. We also are getting involved in more activities. So, for example, we were invited to the special interest group in AI of JONT, that's a European NREN consortium. So we were invited to be part of the special interest group in AI. And their first meeting was held in Poznan, Poland last December, and I attended that, and I presented about this project and how we are doing and where we are and so on. They're also very interested in this kind of capacity building, so we might have future collaborations with JONT as well. So that's something that we are looking forward to. Looking at what we are going to do in this particular workshop. As I said, we got this grant, and we're not just doing the workshop, we're also providing fellowships. So there was a lot of interest for the fellowships. We had 127 applicants. Unfortunately, we could only give 15 fellowships. So whoever who are here with the fellowship, you have indeed been very lucky. Basically, we targeted the LDCs and LMICs, but we are not limiting to that. We have from upper middle income countries as well. We are also looking at gender balance and so on. So the plan for today and tomorrow, we'll start, of course, the welcome and the introduction. And I actually shared a pre-workshop survey. I have to check now. In the morning, I only had 15 um, entries or submissions. So I need to just get it done very quickly because we need to look at the attendance and the audience that we have. As you can understand, as I mentioned earlier, we have a crowd that's going from people who are teaching AI to people who might not be using AI at all, and a mix of all. So we need to gauge where we are, identify what areas you are working on, your views and what you hope to gain and so on. So I'll quickly share next the survey so that if you can quickly, if you have not done, quickly do it so that we can actually have a gauge of where you are and how to move forward. And then we'll have a quick introduction to AI and GenAI, once again, to get everybody up to speed, everybody in the same level before moving on. And also a session on prompt engineering, which is going to be the key part of our workshop going forward. In the afternoon session, we will look at how we can identify workflows, tasks, and paths for improvement. And then we'll have breakout sessions to work on different areas, technical, financial, administration, marketing, and so on. And in the last session, we'll have quick presentations of these planned proposed solutions, just to get a quick feedback and to identify whether we are all in the right track, and so, or whether we need any revision and so on. So tomorrow, we'll start on by looking at the practical and ethical use of GenAI, a quick look at that. And then we will work on finalizing our solutions that we start working today, and we wrap up in the afternoon session by finalizing these solutions and finalizing the presentations, and end up with the presentations in the last sessions, followed up by the wrap up. So that's the plan that we have for the 2 days, today and tomorrow. Any questions, any comments, any concerns? All right. So this is the survey. So if you haven't received this, or if you haven't done this, if you can quickly complete this, that will be very helpful. Sorry? Yeah, yeah. If you have done it, that's fine. I have 18 submissions so far. So if you have not done it, please do so as soon as possible. Okay, hope, of course, we're finishing. We'll just quickly take a look at the results, but if you are still doing it, please finish it. I will just go through the results just to see what we have got. Right. Which country you're from? Okay, we have four people from Bangladesh. Wow. Yes. Bangladesh, Malaysia, Pakistan. Yeah, we have a good mix of people and different places. Of course, it's very hard to find because they'll be written in different ways. Gender, 32 to 11. Which is your current role with the organization? We have a lot of engineering technical staff, but we also have academic staff, and also a good mix of administrative, human resource, finance, management, which is great, actually. How many engineers? Once again, a very good mix of experience and young staff as well. Just again, excellent mix of people. Which of the following tasks are part of your main responsibilities? Still, like that, all that apply. Okay, so we have people with network design, system administration, academic teaching, financial management, incident reporting. A lot of people on. Okay, the largest part is documentation and reporting. Interesting. Which of the current tasks do you currently perform manually? Communication with stakeholders, topping, proposal writing, again top, education content creation, data analysis, report generation, routine data entry. Wow, that's a lot. What skills do you currently use? Technical skills, analytical, communication. So, what is the biggest challenge you face in the current workflow? Time-consuming manual tasks, repetitive administrative tasks. So before moving on, why we are doing this? It's not just for our benefit, but for you to also think about what you do, what are the different tasks you're doing, how are you doing it, what affects your day-to-day work, and so on. Because this workshop, we are not just looking at using technology. Actually, the technology or the tools is not the focus. It's a matter of the focus is really on what you do and how you do it, and for you to think about how you do your work, what affects your workflows, what is blocking your workforce, what are the limitations in your workflows, and so on, so that we can actually, you can identify what needs to be addressed going forward and how technology can help. It's not the other way around. There you look at technology and tools and see where to go and fit it, right? So we will practically do it in the afternoon session. So it's very important for you to think about these things and analyze your workflows, analyze your day-to-day work, so that we can bring that in the afternoon and tomorrow. What tools or software do you currently use? Yeah, Microsoft Office, ERP software, and also ChatGPT, Talent, and other AI tools are there. Sorry. How efficient do you find your current tools when completing tasks? Very efficient to neutral. Okay. How frequently do you encounter inefficiencies in your current flow, if any? There's one who says never. Great, I want to know. From that list. And but there are others who say daily, weekly, monthly, and rarely. Okay, so daily and weekly. It's dominating. It's how how often you encounter these efficiencies. How open are you to adapting new tools? Of course, you are very open, or maybe not really sure, but that's why you're here. What metrics would you use to measure the success of new tools or modules? Increase productivity, improve accuracy, and time saving, obviously. Time saving tops, obviously, right? That's what everybody's looking at. How familiar are you with generative AI? Very familiar. We have few, somewhat familiar, and neutral. So we have people who are pretty good with generative AI, has some ideas, so that's good. Right, so as I said, why are we seeking views on GenAI? To know, what's your views, and also identify the different aspects of GenAI, how it affects your work, what you think about it, and so on, right? And what tools are you using? Definitely ChatGPT is leading, and then you have DeepSeek, the new entrant, who's kind of has become very close to ChatGPT, Claude, Grammarly, Perplexity, with the academic crowd, which is once again great. Of which of these tasks have you used AI or GenAI regularly? Once again, report generation, communication with stakeholders, and proposal writing and education content creation. Okay, so you're already well versed with these activities, which is good. One of the craziest, exciting, innovative ways that you have used GenAI tools? None. Video generation, okay. Cartoon of mine using photographs, that's good. Last time we had people looking for cooking recipes, what to eat tonight, and so on. And so those kind of things are also there, that you can do it, ChatGPT or GenAI, right? Just give me ideas what to cook tonight and give me the recipes. Which aspects of your job do you believe would benefit most from GenAI? Automation, network administration, troubleshooting, writing proposals, documentation and report writing, reply to emails, reporting, documentation, software development, productivity, task management, accuracy, time saving, okay? So time saving is, once again, there's a lot. How do you rate the current readiness of your organization to adapt and integrate GenAI tools? We are already using GenAI, great, highly ready, moderately, somewhat, but need improvement, so great. So, I mean, this is fascinating in the sense that, since last APAN, this last APAN, we had a lot in the not ready at all. And with the 6 months, okay, I was there. So like from the last 6 months, it's the change, because we have had a few other workshops as well in Sri Lanka, in Bangladesh. You see how this is changing the work everywhere, which is very fascinating to see. And that's one of the reasons even Asia Connect project is actually looking at doing more of this kind of training to get everybody up to speed and start using GenAI productively in the workflows and so on. So the change is actually staggering. It's like kind of like, because this is kind of right in this side of the graph 6 months ago. And we're getting a similar crowd, of course. We have fellows and all that, but the change is very noticeable. That's how you see it's changing. How confident are you in potential of GenAI? Of course, that's why most of you are here. What concerns do you have about integrating GenAI into your work? Lack of understanding of AI. Okay, so that we'll try to address today a little bit. Concerns about data privacy. Yeah, definitely that's one of the biggest things, and we'll talk about that tomorrow. Lack of support and training. Obviously, that's why this is, and then we hope to do more and more training, more and more kind of these kind of workshops, and going forward to looking at how we can do. So that's one of the things we will discuss tomorrow in the wrap-up, to give us your ideas as to how and what kind of things can be done, should be done going forward, because there are a lot to be done. And your ideas will be very helpful for all the funding agencies and so on, to identify what exactly needed. So your active participation and feedback is going to be very, very helpful, right? So we look forward to that for tomorrow. Cost of tools, yes, that's one of the other biggest concerns as well. We are currently working on developing cost-effective tools, and hopefully that will be ready soon, so we'll try to announce that as well. Quality and reliability of AI-generated content, yes, that's once again one of the biggest concerns, but there are ways to address it. So we will look at that in the discussion today. Bias in AI, that's again a concern. Once again, we'll look at that. Over-reliance on technology, that's one of the key things that we'll discuss as we go on today and tomorrow, whether it's over-reliance and how do you ensure, where do we stand, right, with respect to technology. How effective do you find the current GenAI tools? They're highly effective to moderately effective to slightly effective and some no idea. Okay, so we'll try to address that. What skills do you think you will need to develop to be successful in a world where AI is increasingly prevalent? Thinking about what do you bring? We'll discuss about this very soon. So analytical thinking, creativity, ethical reasoning, resilience, adaptability, data analysis, and all that. So there are a lot of good understanding about what exactly that we bring into the table when you are working with AI. We will, once again, as I said, we'll discuss about this a little bit in detail. What do you want? What do you wish AI could do for you? Make work more simpler, help me find funds, okay? Assistant in my workplace, do the repetitive tasks, writing emails, productivity, voice control, make my life easy, so yep, whatever way, I don't care, just make it easy for me. Right? Okay, so there was this quote that was actually kind of circulated highly a lot about a year ago. It says, what's the biggest problem with pushing all things AI, wrong direction. I want AI to do my laundry and dishes so that I can do art and writing, not the other way around. Right? So I'm just asking, what do you think of this? Right? What's your take on this one? What do you want AI to do for you? Okay, so let's look at the results. I want AI to do my laundry and dishes. Okay, they're strongly disagreeing. So it's right in the middle. The results are right in the middle, but if you go here, there's a lot who's saying I strongly disagree, so I don't want. So I want AI to do my laundry and dishes. There are some who strongly disagree and some who strongly agree. And there's nobody really in the middle. This is exactly I get everywhere. It's very, very, so there's no middle ground. It's either I want AI to do my laundry or dishes, or I don't touching this at all. There's nobody's like, okay, maybe, I don't know. There's nobody. See, like this is always the case. There's nobody in the middle. Right? It's very fascinating. And then when you go to the art and writing, it's actually like, okay, I don't mind art doing half of it, so that I can do the rest. Which is great, but ultimately, I don't mind AI doing any of these as long as I can use it to generate better outcome, which has kind of the better outcome kind of gets the kind of becomes a winner. So, well, it's very fascinating to see those kind of answers. Future program, maybe yes, no. Okay. Will you willing to become a trainer Okay, so we have a lot because, as I said, we are looking at doing a lot more programs, a lot more training programs, and we are looking for trainers in different countries as well. So, we'll have a contact to see what type of training would you need. Hands-on experience, ability to integrate AI into existing workflows. That is exactly what we are going to look at in this workshop. And what format of training would you find most beneficial? So in-person workshops, of course, always wins the race, but even the other courses like online courses and video tutorial. Okay, so thank you very much. If you are not completed, please complete and submit. Because this is very useful, especially to, as I said, especially providing these results, showing these results to funding agencies and other places to identify, what we can do better, right? So your views are extremely important, and it will show the funding agencies where we need to focus, where their funding has to be focused, and how it can be done. Right, so please submit your input so that we can use it, right? Okay, let's cut off delay, right? So yeah, so it's not hoping to give you time for. Right, so let's get on to this introduction to AI and GenAI. Okay, so as I said, I know there are people who are already teaching and using GenAI and all that, but this is just to ensure that we get everybody into the same page. And also, I normally name this as demystifying AI because there's so much discussion everywhere about AI these days, right? Everything is AI. If you look at our students, everybody's like, everybody wants to do some project, something related to AI. It's just everything AI these days. But what we see is, everybody's talking about AI, and how I see is that you have this story about the elephant and the 7 blind men. Some people say it's like a rock. Somebody says it's like a long thin line. Somebody, you give different definitions to AI by just going and touching and what you feel. So just to get a quick, very big overview of AI, what constitutes AI, and moving on to very quickly to GenAI. Okay, so just to give a very quick glimpse of what AI really is, and then so that we can really identify what AI can do for you, and also how to use it, and how it's affecting us, and how to move forward with that. Okay, right. So what is artificial intelligence? Right. So what is AI? Now the thing about AI is, right, or making anything artificial, is that if you want to make something artificial, you need to know what the thing that you want to create artificially, right? So the question is, what is intelligence then? Because if you don't know what intelligence is, how can you make it artificially, right? If you want to create something artificially, you need to know what it is that you want to make. But if you go and look at what intelligence is, you get a lot of definitions. You can get very different definitions. You get like, intelligence, wisdom, IQ, EQ, rational thinking, and there are a lot of things. And if you look at the definitions, then this is something that has been discussed from Socrates, Plato, to Einstein, and everybody, right? If I ask you what intelligence is, you will give me very, very different answers, right? And the reality is there's no one definition about intelligence anywhere, right? So if you don't have a definition or a specific definition about AI, intelligence, how are we going to create it artificially? If we don't know what we are talking about as intelligence, then how are we going to create it artificially? Right? Well, the good thing is we don't really, uh, you know, don't have to come to agreement on what really intelligence is. We can just define as we go, right? So that's what that has been happening in AI over the years, and we'll look at that as well, right? But before starting, now, when somebody says AI, right? When somebody tells you artificial intelligence, what does it mean to you? What do you visualize? How do you visualize AI? If somebody says AI, how do you visualize? What comes to your mind? Okay, something automatic. Okay, what is it? Knowledge. Knowledge, automatic. Knowledge base that you can access. Okay, great. Any other things that come to your mind when you say AI? Information analyzed. Great. Experience. Okay. Anything else? Not done naturally. Okay. Yeah. What about robot? Robot. Great. Any other? I mean, there are many things, right? What is fascinating about this thing is, now I've been teaching AI for the last about 11 years. And 10, like 10, 11 years ago, when I started doing this, the next few slides are actually from my slides that I had 10 years ago, and which I still use. Because the thing is, when I asked the same question 10 years ago, the answers I got from the students were very different. Now, this is what is fascinating about AI, and why has become a key trend. Because when few years ago, when I asked these questions, the answers almost always has to do something with the movies, and this is what used to remind me of when I say AI, was a movie called AI, definitely, the name is there. And it was a fascinating movie by Steven Spielberg, if you haven't watched, right? And this is the first thing that would normally come to my mind 10 years ago, or even before, right? Or something like C-3PO and R2-D2 from Star Wars, and probably the biggest villain of the last century, Hull from 2001 Space Odyssey, where AI becoming a sentient being, and it's like, if you have not watched the movie 2001 Space Odyssey, it's actually it's a very terrifying movie by the end, because it's kind of shows what AI could be. That was like, but it was like what 40 actually 50 years ago, right? And it's very fascinating, right? But now, then it starts changing, because it was just limited the movies probably 20, 30 years ago. But we saw something start to change in the 90s, when we heard that the sitting grandmaster of chess, Gary Kasparov, getting beaten by Deep Blue 2. And what is fascinating about this also, that Deep Blue 1, it actually was able to beat Gary Kasparov in the first couple of rounds, but then Gary Kasparov could learn to predict what Deep Blue would do, and it beat Deep Blue 1. And then in the next iteration, Deep Blue 2 was able to defeat Gary Kasparov. How did they do it? Does anybody know how they did it? Of course, they had bigger machine, better algorithm, but what did they include in the algorithms to make such that Gary Kasparov could not predict and learn how this machine is playing? What they did is they actually, sorry? uncertainty. What did they do? They, yeah. So they added, yes, they added stupidity. They added, like, it will always make the right choice previously. It added some unpredictability into the thing. It would make a move, which is not optimal. What Gary Kasparov said is, I sent something human other side. Because previously it was like a machine, and it will always make the right move, and you can start predicting what it does. And the computer can see far ahead than Gary Kasparov said. What they say is normally grandmasters can see like 12 flies ahead, which is like a really vast amount of possibilities, but the machine could see even further. So that for Gary Kasparov or a grandmaster, you will see that it's always making the right choice. But once you include unpredictability in this one, now you don't know what it's going to do. Right? So that's how it was able to beat Gary Kasparov, and now I mean no grandmaster can even come close to beating a computer in chess. But then there were other games that was considered a no-go, like Go. And AlphaGo beat actually recently. One of the other things was like Jeopardy. This is a game, if you don't know, it's actually, you are given the answer, and then you have to ask the right question, right? So it's called Jeopardy. So this IBM Watson became the Jeopardy champion in 2011. And this is, now, chess is actually moves, it's calculations, it's numbers. This is language. Right? You're given an answer, and you need to ask a question. So these are the things. That's so we started seeing, computers becoming good in different activities that humans are supposed to be good at, in logic and puzzles and all that. And then suddenly, in the last decade or so, it started to become very commonplace, right? It's the self-driving cars, smart agriculture, smart medicine, and even Google. I mean, Google. It knows more about us than we know about ourselves, right? It knows about everything. You go to one place, and then you come home. Some of the people who are there are in your Facebook friendship recommendations. How are they doing this? Because you're tracking everything. You are doing all these algorithms, everything. They know better about us, better than us as well, right? So we started seeing these things, even though we did not really recognized AI behind it. We started seeing these things integrating into our lives. But everything changed with, ChatGPT, and increasingly now different things, Gemini, and of course, DeepSeek coming in a month ago and changing completely the narrative, right? So now it's kind of, it's in everybody's mind, everybody's using this and so on, right? So this is why, so you see the evolutions, you see what is happening, and then you see it's integrating into the lives of everybody, right? Now, what is AI? Right? So this is not a lecture or looking at the deep depths of AI. This is just to understand where we are coming from in AI, as I said, because different people who are doing AI in different places are talking about different aspects of AI, just to understand what all this about, right? So earlier we said, is it about a thought process, right? Is it about the thought process, or is it about doing things, right? Or it's thought process, reasoning, and a lot of places you're saying it's about mimicking humans, or trying to replace humans. Is it about mimicking humans? So there are a lot of questions about what really AI is. Okay, so we will look at different aspects or perspectives of AI very quickly, not in going to the depths, but just to understand where we are standing, right? And recognize their role in the current field of AI. So when we look at AI, I hope you all can see. So can I just talk without the mic? Okay, fine. Right. So when you look at AI, so there are a couple of things that always come to mind. One side is whether you are talking about human aspect, or rationality. Rationality means doing the right thing. Right? So is it about mimicking humans or doing whatever the humans are doing, or it's imitating humans, or is it we want to do something better, something good? Right? So that's one side of it. Other one is it's the acting side and the thinking side. It's the mental side, the reasoning, knowledge in the mental side, or it's actually complete going and doing things. Right? So we look at all these quadrants. So basically like acting humanly, thinking humanly, and acting rationally, and thinking rationally. So we have these 4 quadrants that we can look at, separate and look at. So we'll just have a quick view of all these 4 areas and see how. So this is where actually AI started 70 years ago, people looking at all these different aspects and how those things evolved and what's its role in the current state of AI. Yes. I think you can all, yeah, we are not recording, right? We are recording? All right. So acting humanly, starting with acting humanly. If you have watched Imitation Games by starring Benedict Cumberbatch, it's about the story about Alan Turing, right? Alan Turing or Alan Turing is kind of where in computer science the Nobel Prize of computer science is Alan Turing Prize. So so Alan Turing came up with this test called Turing test in his paper in 1952. How do you define intelligence? So this Turing test consisted of something like this. That you have an interrogator, and you'll have either a computer or a human behind the curtain, other side, and you can just chat with it and identify whether it's a human or a computer. So if the computer can deceive or get identified as a human by the interrogator, that was a Turing test. So this is then we like to talk about what is called a total Turing test, where you need the physical interaction as well. This might seem very simple now, because when we are chatting with ChatGPT or DeepSeek or whatever, it always feels like somebody is on the other side, a human is on the side. But 70 years ago, 75 years ago, this is actually a very, very fascinating problem to solve. And this is where people started working on. And to do this, right? To do this, the computers needed to do a few different things. So what did the computers need to pass the Turing test? The first one is, of course, what is called natural language processing. So natural language processing is like, so natural languages is what we have, our languages. Computer languages are very strictly defined. You have specific tokens, symbols, colons, and all that. But natural language, it differs, different dialects, different languages, and the way you say things, and so on. So there are lot of different things that change in the languages, right? So understanding the nuances of languages, understanding different meanings of languages, right? So the example I use almost all the time is like, if I say something like ice cream, right? What does it mean? What does it mean if I say ice cream? What comes to your mind? Desert ice cream. Yes? Yes? Any other thing? Yes, of course, you were there. Yeah? Yeah, it's right. So ice cream, so what I really said is ice cream, right? So you can, right? So, but, it depends on, so how do you understand whether it's eating ice cream or screaming ice cream? If I say ice cream, how do you recognize that one? Which one am I talking about? From the context. Yeah, from the context. Yes. So in the context, right? So is you take the different contexts that you get, and then you can understand whether I'm eating something or whether I'm screaming, right? So you can't just look at a word or a sound and identify what it is. You need to identify it with the context and on different aspects of languages. So when it comes to natural language processing, there's so many different challenges that comes in, because in computer languages, you just define exactly what it is. It's very easy to decode. Natural language, not so, right? Knowledge representation. Now, what is knowledge representation? How do you store knowledge? When you learn about something, how do you store it? Now, this is, you see this one, right? When you go and study, like you and your friend, how you learn is very different. And you have sometimes you have people that you study similarly so that you can easily relate. There are some who will really understand in a completely different way, right? Now, the important thing about knowledge representation is not just how you store it. That if you store information, the most important part is not storing part. I mean, we all store, right? You know, you go to class, we listen, or we study, and we are all storing it somewhere. The problem is getting it back, right? Can you get the information back is actually the thing. How you store it, how you represent it, how you define it, how you store it, and how can you retrieve it, right? And can you get the same thing back? So this is what you talk about in the knowledge representation. It's not easy, as you know, and when you do it for all type of information, because we can't define what the information looks like, right? Information can be many things. So how do you really store these things? That's, again, becomes a very important part. Automated reasoning, using this information and answer questions, right? So use the stored information and to answer questions and come to new conclusions. So that is automated reasoning. Can a computer use this knowledge and started reasoning with it? So once again, it's how to do it, because I mean, if you had to explicitly program and do, that's a limitation, right? So can it go beyond that and come to new conclusions, new answers, and so on? Right? Machine learning, adapt to new circumstances and extrapolate patterns, and we will talk about very quickly, because machine learning goes very closely with AI, but it's of course a subsection of AI, and we'll quickly look at what ML or machine learning is down the line. And then moving on to total Turing test, we have things like computer vision, which is area on its own entirely. We have robotics, once again, a completely different area. I mean, AI related, but it's an entire area of AI, and other senses, you know, smell, hearing, touch, all those different things that we get. So there are a lot of areas that have emerged trying to pass the Turing test, right? Starting from natural language processing, automated reasoning, knowledge representation, machine learning, computer vision, robotics, and so on. But the important thing is, now this is kind of changed, but nobody's really interested in passing the Turing test anymore. That actually becomes very simple now in different senses. But nobody really paid attention to solving or passing the Turing test for probably the last 40, 50 years. In the first 10, 20 years, people tried it and realized, you know, this is actually not really a good exercise. So they moved on to develop those fields separately, right? Now, what are we really doing? While we are looking at focusing on the studying the underlying principles of this one. So just to quote, why are we really looking at studying the underlying principles? Because when you really look at passing the Turing test, we need to understand we are looking at two different things, right? Earlier we said when we look at intelligence, right? The human behavior, like if you take the human behavior, there are human behavior that is not intelligent at all, right? We do stupid things. We do completely idiotic things. So those are things that cannot be really, you know, measured or tested at all. And then there are intelligent behavior that is shown by computers, right? Or is not displayed by humans. So there's only an overlap where the intelligence that is shown by humans and the intelligence that is shown by machines overlap. So this is the only part that it actually can capture. And on reality, I mean, if to just to quote from the seminal textbook in AI by Stuart Russell and Peter Nowig, people succeeded in artificial flight when they stopped trying to imitate birds and started learning about aerodynamics and the aeronautical engineering. So their goal moved away from trying to imitate birds and how that we can create artificial flight. And we have moved so far away, so far ahead of birds, right? We have stealth aircraft, we have passenger aircraft, we have cargo aircrafts, and we have different types of aircrafts, because we are not trying to imitate birds anymore, but we are looking at how we can create artificial flight. So in the same sense, the effort to create artificial intelligence is not anymore about mimicking humans, but how we can do things better by developing different areas. So that's basically where we are at when it comes to acting humanly or mimicking humans. We are no longer really bothered about how to mimic humans. Okay, moving on. Thinking humanly. So this is basically area of cognitive science. So this is away from main AI. We will talk about cognitive science probably in AI a little bit, but it does not come under the purview of AI anymore because it has a lot of other things coming into the picture, like psychology, philosophy, linguistics, anthropology, neuroscience, and all that. We have top-down, bottom-up approaches of cognitive science and cognitive neuroscience. So there are a lot of different aspects, but this is not something that we really focus on in AI anymore. And then comes the thinking rationally part, thinking the right thing. So lots of thought. What should I think about? What is the right thing to think about? And so on. And we call this logic, right? So as you know, logic is actually, we teach logic, we learn logic in computer science because it's the foundation of programming languages. So we start by with the logic and build upwards to come to developing programming languages. But it's not something that we actually identify as a main part of AI anymore. It's of course it's connected. We teach logics as part of AI just to with the completeness, but it's not something that people are really focusing on when you say AI. And then finally, we come to acting rationally. We started with acting humanly, and we come down to acting rationally. But acting rationally, or we call it a rational agents, it's about doing what we call doing the right thing. So what do we mean by doing the right thing? Right? Now, when we call right thing, right? Sorry. Because when you look at the real life, it's not just about taking the best decision or the optimal decision. There are many other things that come in the picture, because there's what's called uncertainty. If you are programming a self-driving car, right? How do you define? How do you program it, train it to act? Say, suddenly a rain comes in, or an animal runs in front of you, or a vehicle drives in front of you, right? There's a lot of uncertainty in the world. Now, how do you address this uncertainty? Because the next thing is the resource limitations that you have. When you say resource, it's going to be the computing resource, it could be the memory storage resource, or it's the time constraints that you have. If an animal jumps in front of your vehicle, you can't decide, you can't take 5 minutes to decide the optimal action to take. You need to take the action now. So it's not about taking the best possible decision, it's about taking a decision at that moment, or you're going to die, or somebody else is going to die, right? And we saw these things, like, this how this the effect of these taking decisions, I think in Boeing, I think it's 737-800, right? It's Turbo 8. A few years ago, there was like 4 or 5 crashes together. I think about 4 crashes in Ethiopia and different countries. They had a few crashes within a month or so, and then they actually had to call back all the things and identify the issues in their software and update it so that, so these things can be, controlled better. So we see this when you come to rational agents, that it's a more general view of AI. You identify that you need to do the best, but best is limited by a lot of other things like uncertainty, research limitations, and so on, right? So this is the general view of mainly what AI is trying to do at the moment. So once again, just to summarize, we have these 4 quadrants. We are focusing, we are not looking at the thinking part, those are in any other different areas. We are mostly looking at the acting part. Acting humanly as a whole, we are not really bothered about, but the aspects of that we study as different components of AI. And putting all those together with uncertainty and resource limitations and all that is mainly about creating rational agents. This is basically the current status of AI, if you look at the entire picture of AI as it is. Okay? Moving forward. Any questions before we move on? Or any comments? All right. So I'm going very quickly, as I said. I'm trying to get everybody up to speed so we can actually get into the best part, better part of the workshop, right? Rather than listening to me dribbling on here, right? So the evolving state, as I said, when it started in 1950s, the main focus was on the artificial intelligence and those areas that we talked about earlier, the Turing test and so on. And then we moved on to the era of machine learning in the 80s and 90s. So we saw a different variations of neural networks and other machine learning entities, aspects, algorithms, and so on. And then we see a movement into deep learning in the last decades or in the last 15 years or so, moving on towards generative AI in the last few years. So we see this progression, and it's interesting to see and understand why this is and where we are going, and also to think where we could end up. For example, I mean, the right at the start, with in 1950s, the AI became the hot topic, and all the funding was there, and such enthusiasm. And we see a lot of funding coming in, all the people start working, and then you get the first winter in the 1970s. People realize, okay, people are claiming that we are going to do all this, but nothing is happening, right? And so the funding started drying out in the 70s. And then you see these expert systems, like, you had to saw earlier, this Deep Blue 2 and Watson and all the different expert system coming in with the machine learning. And then you see us again another boom. But it's again quickly dies down, because again it does not come to fruition in the things that they were promising that it will do, right? And then you start seeing again an upward curve in the late 90s and starting with 2000. And now it's actually been going up very rapidly, and in the last few years, extremely rapidly. Now, what changed? Yes. So in the turn of the century, we start seeing more and more data. Like with the digitalization, you start seeing data, and IoT and other fields started creating more and more data. Areas of bioinformatics and other fields started creating even more data, and we have like so much data, or we had so much data with us, so we suddenly had data. So if you really look at the AI area of AI, not many new algorithm or breakthrough algorithms and models have come in the last few years, right, in the last 2 decades. I mean, there are, of course, a few new things, but if you look at the history, not many new groundbreaking things have come. What really has happened is that there's been more data and more computing power, right? So if you look at, if you go and study the effect NVIDIA or the GPUs had, so what's GPU, if you know what GPUs are, the gaming cards or the graphic cards that we had. So it started as, of course, gaming, but they all, if you go and listen to the NVIDIA CEO, Jensen, he will tell you, like, you know, they, of course, funded their operation by catering for the gaming market, but they were always working on creating these GPUs or GPUs where you have so many like thousands of, like if you take the latest NVIDIA GPU, they have like 6,000 processors for a particular thing. They have specialized processors, another few thousand processors. What do? They don't go and do generic work on different things. They do the same operation on across millions on billions of data, right? So it's just the same operation across thousands of processors, same operation. And that's what GPU, so we call this not general purpose, special purpose computing, and there's another word for it. Accelerated computing, right? Yes, that's another word. Can you remember? No. So we had general purpose computing. Normal CPUs is general purpose computing. I have a brain freeze at the moment. It's called, now, I mean, what do you call this? Huh? No, hyper, not hyper. Yeah, I'll tell you the name. It'll come to mind. So it's called accelerated or it's called accelerated computing, and there's another name, but there's a specific, not parallel computing. Yeah, it'll come to me. Not computing is not there. It's not there yet. So it's special purpose computing, but there's a specific particular name for it. It'll come to me. I'll say. Right now, the question is, right? So we have more computing power now. We have more data, and this is where we are seeing it's going in this upward curve. The question is, how far will this go? Will it keep going like that, like a rocket? What do you think? Social saturation because of? Okay, power. Anything else? So, so if you take ChatGPT and GPT, when they came up, when we had 3.5, GPT 3.5, the initial one that come to us, the number of, what do you call, data points that they had. Do you remember the number? It's about, it was in, I think, 600 million data points, I think they had in GPT 3.5. GPT-4, they went up to 1.7 trillion data points. So right from 3.5 to 4, they went from 600 million to 1.7 trillion. Not million, 600 billion to 1.7 trillion, right? So about 2.5 size jump. And then now we have released for O, O1, O3. Where do you think that the amount of data is at the moment? How much data have we gone from 3.5 to 4? We went from 600 billion to 1,700 billion. Where do you think we are at with the data at the moment in, say, O3? Any guesses? Yes, Damayanti? It's the same. Nothing changed. So no data at all. Um, I had one of my best friends actually visiting us in January. He's working as a uh, a senior manager at Google Gemini, creating these agents. So I asked him, where is it going to end? You know, I mean, what's your projection? Uh, where's the next? Where's the next problem? This, you know, you hit AI. He said, we have run out of data. And if you look at so I was watching this Cisco AI summit about again a month ago, and they had this I don't know, the youngest self-made billionaire, apart from Kyle Jenner, who's like the social influencer. The youngest self-made billionaire is called okay, I can't remember his name either. He's actually the company. His company is Scale AI. So what they do is actually create data. Create data is actually curate data to get the data, because data is the biggest problem is data, and then you get the data, you have to clean it up and prepare it to be used by AI systems and all that. So Scale AI is doing that, and also they create artificial data to be used by training. And they said, you know, so like we've basically run out of data at the moment. The other side, okay, so the data, we are run out of data. So we are not generating enough data to go further, but the fascinating thing about this is that the DeepSeek actually showed that it's not just about the data, it's actually doing it more efficiently, better, and in a smarter way. That is what ChatGPT and other engines are also doing now. They're not looking at giving more and more data, they're looking at how to use that data better to give better results, like you see the reasoning, deep reasoning, and so on in GPTs going forward. So this is one side of it. The other side, now, so what the Scale AI CEO, and there's another CEO at that AI summit, what they said is actually the biggest problem is not even the data, it's actually the power. Because if you know, what they say is that everybody who's using AI, ChatGPT or GPTs, were responsible for the wildfires in Los Angeles a few months ago. Wildfires in Los Angeles or California is common, but in summer or end of summer. They had wildfires this time during winter. Why? Because they are using so much water for cooling and all that, so they have run out of water for everything else. And what they say is now, few years ago, people actually welcome having data centers in their cities because it will provide jobs and all that. Now nobody wants to have a data center anywhere near their cities. Why? Because they consume more power than a small city for all the power requirement as well as the cooling. So this is actually the biggest problem at the moment. We have run out of data, and power requirement and the cooling requirements are so huge for this the amount of computing that we do. So we have already hit the kind of the bottlenecks, the two biggest bottlenecks at the moment. So where we go, well, we see where it's going with the DeepSeeks and all that. They are focusing more and more of making it efficient and better rather than just scaling up as it used to be, which would be a good thing. Right, so we will see. Of course, we will see. In the next few months going forward, how it's going to go forward. Okay, as I said, I was hoping to finish this, but since we had to do the survey, we kind of got a bit delayed, but that's fine. We have enough time for the workshop. But let's break for tea, and we'll come back at 11, and we'll quickly finish this one and go on to the next session, okay? Once you stop thinking about it, it'll come. Yeah. You have to stop thinking about it, and it'll come. It'll pop up. Yeah, that's how it works. If you, like, it's what you say is like, if you, when you're thinking about something and you can't remember, it's like, you put a ball in the water and you're trying to squeeze, get it. You have to let it come up and then you can just get it. If you try to grab it, it just goes in. So don't try to.